Chapter 4 is dealing with probability, randomness, and uncertainty. And out of the first 4 chapters, Chapter 4 is the most involved and will likely be the most challenging. But the concepts are fairly basic. If you work through the homework, read through the chapter, you should have no problem with getting through the material, but it may require a little more effort. Section 4.1 is a general introduction into probability. It's talking about probability experiments or trials, which are simply just the process that results are determined by chance, a pretty basic concept. It talks about general definitions, things like outcomes, which are the possible results of a trial. Sample space is the set of all possible outcomes for a trial. And then event is a subset outcome from a sample space. It also talks in section 4.1 about subjective versus experimental probability. Those are interesting concepts. Subjective probability is an educated guess, whereas experimental probability is you select a sample and simply take the successes in the sample divided by the total possible outcomes in the sample, and you come up then with the probability based on your sample, which is experimental probability. Through the law of large numbers, we know if you repeat a trial or an experiment over and over and over, as you get larger and larger and larger experiments, and then you average the experimental probability, over time you're going to get closer and closer to the true, or what's sometimes called the classical or theoretical probability, which is also discussed in the section there. So be sure you are comfortable with experimental versus classical or true probability. In section 4.2, the text talks about null events in terms of the likelihood of probability. A null event is a likelihood that the event has a 0 chance of happening, whereas a certain event is the likelihood that an event has a 100% chance of happening. So on a scale then, probability can go in decimal form from 0 to 1, whereas 0 is the null probability, 1 is a certain probability, and most all probabilities lie somewhere in between. Just a real basic example, if you were to look at these 4 markers, then the total number of markers is going to be 4. We have 4 markers, 1 of each color. What's the probability that we select the green marker? Well, then it's obviously going to be 1 out of 4, or 0.25. So each marker would have a 1 out of 4, or 0.25 chance of occurring. Also, complement of an event is interesting. So back to our example, probability of a green marker is 0.25. What's the probability of not a green marker, which would be the complement, is going to be then 0.75 or everything else. So complements are the chance of something not happening. So if you have a class and you do a quick survey of males, females, and say you have 40% males, well then the complement would be probability of not males, which would be 0.6 or 60%, which in that case turns out to be equal to the probability of females. So sometimes, oftentimes, the complement may also mean something else entirely. And then we get into the additive rule, section 4.2, the addition rules for probability. So be sure you're comfortable with that. Think of the addition rule, associate that with the word or. So when we're thinking about the addition rule, which is adding probabilities together, So if you were to say the probability of A plus the probability of B, you can think of the addition rule as the probability of A or B. So the probability of A or B is going to be the probability of A plus the probability of B if the two events are mutually exclusive. If the events are not mutually exclusive, then the probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B, which gets us into our multiplicative property or rule of probability. We'll talk about that in a second. So be sure you're comfortable and go through some examples and work some of the problems to make sure you're okay with it. Additive rule for probability, and also the concept of mutually exclusive or not, because that's going to change the formula slightly. If events are mutually exclusive, then it turns out that the probability of A and B is 0. So then that would just fall out of your equation. Now section 4.3 gets us into the multiplication rule of probability I was just mentioning. One of the keys there is being comfortable with the concept of independence. Are two events independent or not? If two events are independent, then one event occurring does not affect the probability of the other event occurring. If the two are dependent, then one event occurring impacts or changes the probability of the other event occurring. You would see lots of dependent events if you were perhaps looking at probability for, say, cards. Within cards or card tricks, you're going to get some dependent probabilities when you remove one card from the deck and then continue to work with your probabilities, because you're going to be dealing with one less card. So selecting one would have an impact on the probability of selecting another card. So the multiplication rule of probability then, probability of A and B, if in fact the two events are independent, is just going to be the probability of A times the probability of B. Now if you have the case where the two are dependent, then you get into what's called conditional probabilities. Conditional probabilities are typically denoted as probability of A given B, and that's written as probability of A slash B, or you could read it as probability of B given A, depending upon the direction. So if we're dealing with dependent events, then the probability of A and B is going to be the probability of A times the probability of B given A. Or you could write it, the probability of A and B is the probability of B times the probability of A given B. And that's on page 217, and they're using, instead of A and B, they're using letters E and F. So you have to be comfortable with what the concept is of independence. You have to be comfortable with then whether you have a conditional probability or not, as to whether then that's going to change your formula slightly. On 219, they give you a slightly deeper definition of the conditional probability. So say probability of A and B is going to be the probability of A, the probability of A given B is the probability of A and B divided by the probability of B. So you need to work through those to make sure you're comfortable with conditional probabilities. Section 4.4 talks about factorials and the combination and permutation rules of counting. Factorials are pretty basic, oftentimes written as n factorial, so you can put any value in, say 5 factorial, and factorials are just simply multiplying in descending order. So 5 factorial is 5 times 4 times 3 times 2 times 1. 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and so forth. So factorial should be pretty easy. Also, combination rule and permutation rule on page 229 then give you the rules for a certain number that's going to be of a sample included and how many we want to pick out per se. So if we're talking about a combination, a selection of objects from a group without regard to their arrangement, so order doesn't matter, whereas permutation, selection of objects from a group where the arrangement does matter. Now for factorials and for permutations and counting rule, I suggest you use your calculator. It's helpful. So for example, I'll give you an example. You would put in, let's say that we want to say a horse race. We're in Kentucky, Keeneland's about to start. A horse race starts with 10 horses, and we want to know without order, so combination rule, what's all the different ways that 3 horses can finish, the top 3, without regards to order, with 10 horses in the race. So we'd put in 10, you hit the math button, go over to probability, go down to number 3, which is the combination rule, and hit enter. So now you should be reading 10 NCR, that's the counting rule. This is going to be 10 combination, and then put in 3, enter, and you get the value of 120. So what that's telling us then is out of 10 horses in a race, if you don't count order, what are the different possibilities of 3 horses out of the 10 finishing in the top 3 if you don't count order? And the answer is 120 possibilities. Now with permutation, you're going to include order, so now you can count the same 3 horses different times if they're in different orders. So to do that, you go back to 10, math, probability. Number 2 now is in permutation R, put 3 again, enter, 720. So if you count order specifically, if you have 10 horses running a race, then there's actually 720 different possible outcomes, if you include order, for the top 3 categories. It really makes you think about counting and probabilities in a little deeper way. 720 possibilities. And I encourage you, if you don't believe that, to sit down, list out 10 horses, maybe even give them names, and start writing out all of the different ways that those 10 horses can finish in the top 3. Include order, you'll come up with 720, although it may take you several hours, maybe even several days to complete that task. I think I would trust the textbook and the calculator. So be sure you're comfortable with combination and counting rule. 4.5 just continues the same discussion on combination and counting rule, which it flushes out the formula a little deeper. So be sure you're comfortable with working through the formulas, which include factorials, to see how we do those, although again, the calculator is the easiest way. I'm looking on 239. There's an example there of 36 permutation 5. You should be able to see pretty easily that it is quite a bit simpler to use the calculator than to do the math involved there. But you need to be able to do the equations as well for elementary problems. Okay, so that concludes chapter 4. There's a lot of material there. There's a lot going on, but you're going to have to take some time. Now, chapters 1 through 4, lessons or homeworks and quizzes are actually due by next Friday, the 19th. So hopefully you have worked through most of chapters 1, 2, and 3. You can spend this final week working on chapter 4. And then exam 1 will post on the 19th, which is next Friday, and it will remain posted until Monday the 22nd. But you will have to complete that at some point over the 4-day period. So you should be hopefully moving into chapter 4, getting ready for exam 1. Please let me know if you have any questions or concerns about the material or the class.